All right, I'll go ahead and get started. My name is Dave Wright. I'm the founder and CEO of SolidFire, and I'm going to talk about really what I see as the future of storage. We've got a little bit in here about our product, but I really want to take this opportunity to talk about where the storage space is going. And I don't think you can talk about where storage is going without talking about the big shift that's taking place in the landscape of IT across the board. And I think there's a couple of big trends that we're seeing, and there's a divergence in where computing is going. You've got computing going to the smallest scales. We've got to move from desktops to laptops to thin clients to tablets down to your smartphone. So computing power is shifting into a more mobile, smaller form factor. And then you've got to shift to the large scale. You've got an adoption of public cloud like Amazon. You've got adoption of private clouds. You've got big data, where there's now a push to aggregate more and more data to get business intelligence out of it. And the larger data center that you have, the easier that you have doing that. And the net result is that everything in the middle is getting squeezed. PC sales are down. Small-scale server rooms and data centers are much less economically attractive these days. And mid-range storage itself is really getting squeezed by both ends of the spectrum here. I'm not going to come up here and give a big pitch on cloud. I think people understand why the shift to cloud is underway. Coming from Rackspace, where I was at prior to SolidFire, I saw this firsthand. The simplified management, the elasticity, the rapid deployment model that you can have with cloud, the ability to pay as you grow, shifting CapEx to OpEx, the developer-centric nature of the cloud. All of these things are pushing this migration to cloud, and fundamentally it's allowing information technology professionals to become enablers rather than roadblocks in the IT process. And if there's really any doubt about this, all you need to do is look at what's happening on both ends of the spectrum, both at the startup and at the Fortune 500 companies. If you look at startups today, no startups are spending their capital on their own infrastructure. Nobody's going out and raising a round and building a data center as happened a decade ago. These startups are exclusively cloud. And the startups that get to a large scale, large enough where the economics of running things in-house make more sense than paying a public cloud provider, they're just bringing the cloud in-house. They're looking at building the same type of infrastructure in their own data centers that they're using in the public clouds. Folks like Zynga and Facebook are able to do this. And some folks, even at scale, are still in the public cloud, people like Netflix. If you look at the Fortune 500, we're obviously seeing adoption of both public and private cloud there. You've got SaaS applications, things like Box.net, Basecamp, that have snuck their way into a significant portion of the Fortune 500. And then you have stories like HP, the largest IT company in the world, moving to SaaS applications like Salesforce and Workday. If HP doesn't want to run the applications internally anymore, what does that mean for everybody else? Of course, you've got headlines like this, like EMC missing their revenue mark recently, blaming a global dip in IT spending. But I think realistically, we know that people aren't buying less storage. There's not less data being consumed. All the numbers we see say there's more and more data being created every single day. So if storage revenues are flatlining or dipping, it's because the data is going somewhere other than where it used to go. So that brings me to my soap opera, which I call Mid-Range Storage, One Life to Live. And my point here is simple. I think that the next generation entry-level mid-range storage arrays, a lot of the technologies that we're going to be talking here today, they do have clear advantages over the legacy systems they're replacing. The intelligent use of flash, the performance benefits that you can get there, a simplified provisioning model compared to legacy systems, the efficiency that you can get with data reduction. These are all significant advantages over what's there before, and there's going to be a lot of adoption of those as a result. But the question is, how much longer is that relevant? And I fully believe that there is probably one more adoption cycle, one more purchasing cycle of mid-range storage here over the next 3 to 5 years. But really what you're seeing is just people buying time on the inevitable migration to cloud. Because buying storage at that scale, at the scale of 10 terabytes, 20 terabytes, 50 terabytes, 100 terabytes, and actually running and operating that yourself, it's just not going to make sense as we go forward here. The future of storage is all about the cloud. It is all about scale. And folks may say, well, look, it's not here today. People are not putting a lot of these applications into the cloud today. It just isn't possible to run a lot of the things that people are running on these mid-range arrays in the cloud as it exists today. And I think that's true. If you look at where the cloud is today, it's down here. It's in the bottom left corner. It's applications that don't require a lot of performance, that don't require a lot of consistency, test development, backup and archiving use cases, startups with their applications that they're deploying in a cloud-native fashion. And it's not up in the top right corner. It's not the performance-sensitive apps. But that really represents an opportunity. That represents an opportunity for these applications to move into a cloud environment. These applications that are more demanding. It's not that people want to run them all in-house. It's not that people want to run them on siloed architectures. There's a lot of advantages to running these type of applications in either a public or a private cloud context. But the technologies that are out there today just don't enable it. If you look at some of the things that are really needed to enable running these higher performance applications in a cloud, there are obviously things like higher levels of performance, quality of service and hard SLAs, the ability to get to the scale needed to run these applications. Because individually these applications are quite large. If you take hundreds of these applications and try to put them in a cloud footprint, the scale that you need to support that is significant. Reliability and security are also obviously very critical when you're dealing with these enterprise applications. So that really brings me to the kind of key point here. And this is something that, again, I was able to see firsthand at Rackspace, and it's fundamentally why I started SolidFire, which is that traditional enterprise storage doesn't solve those problems. It doesn't allow you to get to cloud scale and run these applications. The storage that allows you to run these applications in a traditional siloed enterprise data center is not going to allow you to run these things in a true cloud environment. So what do you really need? What does the cloud really need to be able to run these applications successfully? And I think there's 4 key elements. The first is what we call performance virtualization. You'll hear a lot of people talking about Flash and the performance benefits of Flash. And Flash certainly is fast, but performance alone isn't enough. You need control over that performance. Second is efficiency. You need to be able to get to high levels of efficiency with your storage to make it work at scale in a cloud environment and to make it cost effective. The third area is automation. The cloud is built around automation, and automation is essential to being successful in the cloud. And then the fourth is simply cloud scalability. You can't build a cloud out of islands of storage. You need to be able to get to massive scale for the cloud to make sense. So I'll talk about a little bit of these in more detail with some specific examples. Performance virtualization, what do we mean by that? What is that all about? So one of the big issues with performance in the cloud is the noisy neighbor. It's the idea that it doesn't really matter how much performance you have. When you've got a multi-tenant environment, a multi-application environment sharing a set of shared resources, you've got to deal with that guy, the noisy neighbor, the guy that causes problems for everyone else because he overutilizes the shared set of resources. And this is exactly what you see in typical multi-tenant environments when you have somebody that has a spike of activity. And on the compute side, in virtualization, this problem has very much been solved. The hypervisors these days are very good at allocating resources, dedicating resources, and ensuring that, by and large, applications don't directly interfere with each other. But this is a huge problem on the storage side today, and this is one of the big things that SolidFire has tried to solve with our performance virtualization technology. And what we've done is develop a system where you can separate performance from capacity and allocate them out individually. And give applications exactly the capacity that they need as well as the performance that they need, and then guarantee that performance and actually set SLAs around that storage performance, even in a multi-application, multi-tenant environment. The net result being the elimination of the noisy neighbor. So secondly, efficiency. And efficiency is something that it isn't optional in the cloud. It's essential. The cloud is really defined by efficiency. That's why you're able to get the economics that you do in the cloud, is because of the efficiency that's achievable there. And that efficiency is really defined by entirely different metrics than what traditionally storage has been viewed on. It's not just about dollars per gigabyte or dollars per IOP. It's about the efficiency of the storage when it comes to power efficiency, gigabytes and IOPS per watt. It's about the density that you can achieve in terms of virtual machine density and, to a service provider, revenue density in terms of the actual footprint. Even things like the weight of the systems, how much you can physically put on a square foot of floor space, actually really matters when you get to these massive scales. The second thing is it's about utilization. Obviously, if you have the best storage system in the world but has a very low amount of utilization, you're not going to have a very efficient system. And I would say that scale out is a very important part of the utilization story. It's not something that's talked about a lot because almost every storage system has thin provisioning and other technologies like that today. But the reality is, if you don't have scale out capabilities in your storage system, you can't effectively use those technologies. If your system is highly thin provisioned and highly utilized, but you can't add capacity and performance as that thin provisioned space is used, you're not going to be able to do it. And you're going to have to do what most people do, which is buy 3 years worth of capacity, fill it up over 3 years, and then look at an average utilization rate that's extremely low. The only way to consistently get high levels of utilization is if you have a storage system that you can run at a high level of utilization, and then you can incrementally add capacity as it's consumed. And then finally, native data reduction is absolutely essential. The benefits, and you'll hear many people talk about this today, are significant. 5 to 10x effective increase in capacity if you do data reduction well, if you have native compression deduplication built into the system, and if you can do it without the performance impact and trade-offs that typically come from compression and deduplication. So automation is the third bullet here. And obviously this is getting a lot of focus these days with buzzwords like software-defined data center, software-defined networking, software-defined storage. And really what those things are talking about is automation. And automation is a central tenet of the cloud. And it's really what makes the cloud what it is today. But I think it's also important to point out that software-defined is not a sales model. There's folks out there that sell storage software that say, well, this is software-defined storage. And that's not really the case. It's not about how you sell your storage or how you sell your networking, whether you sell software and hardware together or sell them separately. Software-defined is really about how you separate the orchestration and management of the infrastructure from the infrastructure yourself, how you integrate multiple levels of infrastructure with standard-based APIs. That's what makes a software-defined infrastructure. And building a storage system for this kind of software-defined data center for a cloud infrastructure is something that I fundamentally believe has to be built in from the start. You need APIs, but you don't need bolted-on APIs. You need APIs that are built into the core of the system and are completely comprehensive across 100% of the functionality. You need multi-tenant functionality built into the system, provisioning, reporting, all of those things that are built into the architecture and not have to be bolted on later. So all of these things are essential to be able to get the level of automation in a system that's required for the cloud. And integration is important as well. And again, integration at a very deep level with the types of cloud management stacks, the type of orchestration layers that are being built out there to build out these large cloud environments. So the last thing I want to touch on is cloud scalability. And again, I think this is important as we talk about what separates SolidFire from some of the other companies that are speaking today and other companies that are out there in the market. And it's this idea that really the bar for scalability is very different when you deal with these large cloud environments. And as a result, we've built a storage system that has a completely different scalability profile of other things that you'll see in the market today. And the way that we look at this is a graph of performance on the vertical axis and capacity on the horizontal axis here. And if we graph out other storage systems in the market today, if we look at other flash storage systems, they have relatively high levels of performance, but they don't go very far on the capacity scale, at least for a single system. You need multiple systems to scale out your capacity. If we put the disk-based systems out there, obviously you can get to massive amounts of capacity, but relatively low levels of performance, even if you have a flash tier or a flash cache. By comparison, SolidFire with our scale-out all-flash architecture is able to deliver a massive range of capacity and performance, upwards of 5 million IOPS and 2 petabytes of capacity, but starting as low as 60 terabytes and 250,000 IOPS, and incrementally growing as you need it. And this is a profile that we think is a much better fit to a large-scale, heterogeneous cloud environment where you have a range of applications that need a lot of capacity and a little bit of performance, as well as applications that need a lot of performance and a relatively little amount of capacity. Stephen, just before we started here telling me is, he said, look, I only need 2 gigabytes of space, but I need a lot of performance for my applications. And that's a perfect fit for a SolidFire environment because we can mix those applications using our performance virtualization technology with other applications that may need terabytes of capacity, but a few thousand IOPS. And that's really the advantage of the SolidFire architecture here. So that's it for me. I'll be speaking on some of the panels later. SolidFire is having a big announcement next week. Certainly come by our website and hear more about that. But we are an all SSD solution designed exclusively for large clouds. Thank you very much.